The two options of stores set to make expansion that we're looking at are this food company that already has 5 locations, and they're tacking on plans for 20 new stores a year. Seems pretty ambitious. They might have hit large on Shark Tank is what I'm figuring. But we don't have that information, so we can't assume. But store A, or plan A, 20 new stores a year. You'll also notice on the next page, plan B, is to double the number of stores each year. Which you might be thinking for scaling up, right? 5 one year, 10 the next. 10's not 20. Maybe that'll be a little different. Your job is to fill out the tables and answer the questions about these store expansions. And we're going to look to see what's the same, what's different. And maybe we'll pick. Maybe we'll pick store A or plan A or plan B for expansion. One maybe is better than the other. All right, so let's do this. This one is increasing by how many? How many is this one increasing by? Plan A? 20 years. So you guys get something like 45, 65, 85, 105, 125, 145, 165, 185, 205. Something like that. Is that what you guys got? Yeah. And then from previous year, boom. Plus 20, plus 20, plus 20, plus 20, right? You all good on all that? Now, what do we notice about the difference year to year? Who can summarize what's happening to the difference year to year? Not a trick question, friends. Sean?
It's constant.
Yeah, I'm going to write this really samesies. Okay? It's constant. It's a constant rate of change, 20 per year. What is that 20 per year in context? What is that? What else can we call that in math, Maddie? What is it?
N plus 20.
So the year before plus 20. Oh, so you're going to the next one. Okay. N plus 20. But I heard someone over here say slope. It is the slope. So I'm just going to write, we don't need this, but I'm going to write the slope's 20. I just like to identify that in context, 20 per year. And then Maddie got us, for a year later, we take whatever the year before is and we add 20 to it. If we know the year before, we always know the year later because it's 20 more. Okay, what about for 3 years? What you thinking, JP? Yeah, so I would write this, well, what'd you say? I just couldn't hear. 60 more. So we could do n plus 60. You could also do something like n plus 20 plus 20 plus 20. Or you could also consider n plus 3 times 20. All those are kind of the same thing, right? I kind of like the 3 times 20 in my head because it says I'm adding 23 times, but all these say the same thing. So if there's n stores 1 year, how many will there be in 3 years? Again, these are all kind of the same thing. This one, oh, I kind of already did it. The answer up there is 60. N plus 60, or any of these would work there. Whatever it was, there's going to be 60 more because it's 20 a year for 3 years. We good? I did extra up here. This one would just be 60 after 3 more years. On this one, I'm not gonna fill out the whole thing. But if I got 5 stores and I double, how many stores I got? And I double that, 20. I double that, double that. Okay, now I gotta finish. 160, 320, 640, 1280, 5, 5, 0. No. Which one is? Oh, I got ahead of myself.
50, 120.
I got ahead of myself. So, I'm not going to do all the differences. I know I said I wasn't going to do all those, but all the differences from the previous year, I had 5, 10, 20. You're going to notice something kind of like, you guys notice something like that going on? And then the factor from the previous year, it's always a factor of 2 difference, right? Because I'm doubling it, man. I'm doubling it. So, what do we notice about the difference year to year? Did it stay the same or did it change? Sean? The difference doubled year to year, so increased. I'm just going to write increased. It didn't stay the same. Last time it stayed the same because there was a slope. There was a constant rate of change. It no longer is constant. So we know right there, as soon as it's not constant, it isn't what? What type of function?
Linear.
It's not proportional. It's not linear, right? Okay. Now, things that aren't proportional can be linear, though, right? Like a line that starts anywhere else. It's all right. So what do you notice about the factor year to year, though? The factor is times 2 over and over, so I'm going to say it is the same. It's times 2 every time. So this time, instead of being our difference being the same, our factor's the same. That's because this is a different type of function. So if there's n stores in 1 year, how many will there be next year? Meredith?
What question is this?
2C, though.
Well, there'll be double.
Double. So I'm going to write this. I'm going to write the expression 2n, or n times 2, either way. It's doubling. Who can tell me every 3 years? What's happening every 3 years then?
Times 8.
Times what? Times 8. I'm just going to write that. Times 8.
Yeah, I just said n times 8.
So, that's for the difference every 3 years? The difference is times 8? What about the factor every 3 years? Yeah.
Oh, that would be.
Oh, I answered for 3C.
Okay, 3C. Well, let's talk about the factor every 3 years. Does the factor change every 3 years? It just stays 2, right? So the difference changes every 3 years, but this factor is always times 2. Ivy, you want to hit me with C?
Yeah, I got n times 2 to the third power.
N times 2 to the third power. Here's what I got. I'm just messing with you. Same thing, but I did get that as well. N times 2, or we're going to have n times 2 times 2 times 2. All those would be the same. I'm multiplying by 2 3 times. This is actually my personal favorite. Right there. Now I'm going to hit you with something a little extra. Don't write this down. Just hear me out. Okay, Cam's going to help me. You ready, Cam? I'm just going to answer your question. I'm asking you a question. You're going to answer. How many stores do we start with?
10. Oh, 5.
10's the first one I wrote down. I see what you did there. No, you're good. So we're starting with 5. What's happening to them? Doubling. So if I wanted to say what's happening to 5 in math times what? You got it. 2. So I'm going to do 5 times 2. And then, does that only happen once, or are there a variety of times that could happen?
Yeah, a variety.
So check this out. Don't write this down. This is what we're going to be moving to tomorrow. This is the function f of n, if m is the number of years, that it's going to double. And here's what we're going to work on. Concept, right? I'm starting with 5. It's doubling how many times? Well, it depends. If it depends, what do I put in there for the thing that depends? A variable. In this case, it is years n years. So that's what we're going to be moving to. I just like to throw it out there because you guys can use things you already know kind of to like understand it. Versus when we hit a lesson, sometimes I get a little leery because it's going to say something like initial value times the growth or decay factor to a variable. And then that's like, I'm just showing you guys already like, you're already there. We're just going to work on piecing it together as we go through the next couple of days. All right? Anybody need more time? I'm feeling like maybe? No. Okay. So, situation 1. Let's get all these social media ones. Who can give me one thing that's going to match? The social media one. Maddie. Hey. Times 3 times 3 times 3 times 3. Triples 4 times. Okay, I need another match. Ivy. Which one? B. Check out those outputs. Times 3 times 3 times 3 times 3. Ryan, last one?
F.
F. How'd you know that was... I don't see 81 anywhere.
Because if you multiply 3 times 3 times 3 3 to the power of 4.
Yeah. Actually, A, B, C, D, E, F. Uh-oh, I don't know my alphabet. Just kidding. G. I actually like this written as 80 times 3 to the 4th myself. Also equivalent, though, right? Okay, so by the process of elimination,
I wonder which one's on the other one. Just I wonder.
I'm adding 3 4 different times, increasing by 3 4 different times, adding 3 4 times. Another thing you could write, just to even things up, A, B, C, D, E, F, G, I, maybe we could write 80 plus 12 if we wanted another one. Actually, I know, Sean. I'm just messing with people that aren't going to like that. All right. That's it. Well, let's get you cooling down, and then we're going to get you that homework.
Jackson